Well, probably we spent like more than 1 hour, about 1.5 hours on this example. That's, you know why we should spend such a long time on this example. The first thing is that you will see a similar question in your homework, that's for sure. And most likely you will see similar questions in your final exam. I hope everybody should review this question very carefully. Make sure you understand how to use the priority rules to make the order of sequence. And how to calculate these 3 measurements: average flow time, average hardness, and average number of jobs. Since most likely you have to use them in your homework and exam. So next topic we'll discuss is 2 working center sequence. So the first example we have went through is still pretty simple. Okay, we think all these 6 jobs goes to 1 working center, 1 machine. Okay, so this machine can only handle 1 job at 1 time. Okay, and then we have to make the sequence by using different priority rule. But if it's more complex, we have 2 work centers, which means okay, job A. If the job A has to go to the first working center, WC1, and then the second working center. And finally, go outside, finish job A. So if that's the situation, it will make our schedule more complex. After we study this situation, we know that it can be easily extended to 3 working center or 4 or more working center. So basically, from 1 to 2 is a big step. That's what we will study in today's class. Okay, so Johnson's rule is used to minimize the max span time for a group of jobs to be processed on 2 machines or as 2 working centers. So the goal is to minimize the total max span time, which means okay, if you have, for example, 3 different jobs, right? All of them has to go to the first work center and the second. If all of them have to follow these steps, then our goal is to minimize the total max span time. Okay, the total time we spend in these 2 working centers. That's our goal. Okay. If we reach this goal, we'll minimize the total idle time, which means the waiting time for those 3 jobs, summation of these 3 jobs are minimized. And we need several conditions. Those are the conditions. Okay. Conditions 1, the job time must be known and constant for each job at work center. And job times must be independent of sequence. And jobs must follow same 2-step sequence. And all jobs must be completed at the first work center before moving to the second working center. Okay, so wait for a second. Okay, here's that. I should post the latest slides. Anyway, we have that.
What? There are more slides?
Yeah, just 1 example. Don't worry about that. All the other things are the same. So here's the conditions by using Johnson's rules. Okay. So we must know the job time in advance. So for example, job A is 5 hours in working center 1 and 3 hours in working center 2. This must be known in advance. And independent of sequence, which means if you process A first, B second, or B first, A second, it doesn't matter. The time spent on each working center is independent, is fixed. And the third assumption is that it must follow the same 2-step. Okay. All these 3 jobs, they must go to the working center 1 first and the working center 2 second. Same sequence. The last assumption is that must go to the first work center before moving to the second work center. Okay, so Johnson's rule. Let me read that, then we'll go to the example that we can understand how to use this rule. Otherwise, it's hard to understand this rule. We first list the job and their time as each work center. We know the job, the process time for each job for each work center. And then we select the job with the shortest time. If the shortest time is as the first working center, we schedule the job as the first. If the shortest time is as the second work center, we schedule as the second work center. Well, if there's a break, okay, break ties, arbitrary, truly anyone, okay, if there's A and B has a break tie, has a tie, you just choose B, A or B, and it's anyone you like. And if you already scheduled job, you just eliminate the job or delete the job from further consideration. Repeat step 2 and 3 until you schedule all the jobs. That's the sequence. So let's go through the examples. Because we have plenty of time. Usually some semester I skip this example, but this semester we have the luxury, we have enough time we can spend on this example. These 2 working centers. So a group of 6 jobs to be processed through a 2 machine flow shop. The first operations involve cleaning, and the second involve painting. We want to determine a sequence, okay, like A, B, C, D, E, F, like first come, first serve, right? But we want to use a Johnson's rule to determine a sequence, minimize the total completion time of these 2 jobs. So, of these jobs, those 2 jobs, in 2 work centers. So, if we go to the last lines, we want to use the Johnson's rule to find the sequence of these 6 jobs. Right? First step, we list the job and their time at each working center. Have we done this step?
Yeah.
We've done, right? It's already listed here. The hours are clearly listed here. Let's say it's 5 hours, right? And the second one, select the job with the shortest time. Which job has the shortest time?
D.
D? Very good. If the shortest time is as the first work center, schedule the job first. If the shortest time is as the second work center, schedule job last. That's no break ties, so those ties, so basically just D. So should we schedule D as the first position or the last position? First position. Why? Yeah, it's the shortest time in the first work center. That's great. So we know that's okay. We should process D first. Very good. Next job. So we eliminate the job. Okay, we don't consider D because D already have his position first, right? Repeats because there's still 5 jobs we need to schedule them. Repeats, come back to step 2. Still, among the rest 5 jobs, select job with the shortest processing time. Now you delete the D. When you do that, you should cross this line. This D. For the rest, who has the shortest processing time?
B.
B. Very good. Then what position we should schedule B? Last. Franco say? Here. Why?
Work center 2.
Yeah. Because this shortest processing time happen in work center 2. Then we need to schedule B as last. Okay. Now we should delete D and B. We come back to step 2. We find another shortest processing time among the rest 4 jobs. Then after delete B and D, which one has the shortest processing time? A. Great. That's a ties. So who do you like? What position do you like? Is the first or the last? Let's say it's first, right? Okay. Let's say it's because it's a tie, right? So let's put A after D, because D is the first, and then for the rest job, A is the first. Okay, then we delete D, B, A. What's the next one?
E.
E, with center 1, right? Still first. Next one?
D.
C, with, yeah. And the last one is F. So that you can say that is you. If you follow this is one sequence. But if somebody say, okay, if we determine D and B, and since A is a tie, that's you. If you like to put A is a tie, put A in the last position, it also makes sense. Arbitrary, right? Because it's 5, right? If that situation, then what's the next? E, right? E, right? So E is E is here, C is here, F is here. Both, if you write either of them in your homework or exam, both I accept that. Because that's a tie break. It's arbitrary, right? Okay. Let's focus on the first one. Now we know the sequence, right? D, A, E, C, F, B. But we also need to calculate the completion time, or it's called also called make span time, to finish these 6 jobs. We need to draw a picture. I'm not a person good at draw the picture, but I will try. So work center 1. Okay. First, we process job A. How many hours we process job A? 10? Work center 1.
Wait, what A?
Just work center 1.
Why?
5 hours, right? So here we stop 5 hours for A, right? And then for work center 1, the next one, sorry, close for A. My mistake. That's why you are confused. So it's D, right? So it's D. How many hours?
2.
2 hours.
D.
These 2 hours. Let's make it short. D. 2. The next one is A. We spend 5 hours. But in the meantime, for working center 2, we begin the job as the 2 hours. We begin to process which job? D, right? Because we want to minimize our time. So we begin. First 2 hours, just waste work center 2, because then nothing can be processed in work center 2, right? Only after 2 hours, we finish job D, we begin to process job D here. Until 7 hours. So it's 9 here. Okay. But let's first finish work center 1. We come back to work center 1. Work center 1 is pretty simple, okay? After A, which job? E, right? 6 hours. So we finish that. Should be 7. 7, 2 plus 5. 7 plus 6 is 13 hours. Here is 2 plus. Okay. And after E, which is C. C is 8 hours, so 21. And then F is 6. Sorry, what's 6 is 12. So it's 33. And the last is B, which is equal to 37. Am I right? Right? Yeah? Right? Okay. So you can see work center 1 is pretty simple. After we have a sequence, we know that 37 hours, we finish. But this is not the completion time, because the completion time should be every job finish in work center 2, which is a tricky part. Let's come together to do that. Okay. Job D, 9 hours, right? Agree? First 2 hours are blocked or just waste. And then we begin to process D after 2 hours, right? We spend 7 hours. After 9 hours, we finish job D. Now we can begin to process the second job. Which job we should process after D? A. How many hours do we need? 5. Then it's finished on 14. Right? Continue. Next one, job E. 8 hours. Then it's 22, right? 22. Job E, right? After E, which job? C. 9 hours. So it's 31. Okay. That's a tricky part to have. 31. You can see the problem here? Can we go ahead to process job F now? After 31 hours. We finished job C in second work center. Can we process job F now? Why, Jack?
It doesn't finish processing until 33 hours.
That's right. So we have to spend 2 hours as idle time until 33. We can begin process job F until it's finished in work center 1, and until F is 15 hours. So 48 we finish F. The last one is job B, 3 hours. Finally, we spend 51 hours to finish all these 6 jobs. So the question, if I ask you, okay, what's the total completion time or make span time? That's the result, 51 hours. Okay? You may get a little bit different results if you use the second sequence, but it's okay because that's the break ties rule, arbitrary. But use the same way, you can find it. It's very important when you do the homework exam, right? It's very important. Work center 1, don't worry about you guys. Just you have a sequence. It's easy to write stuff. But when you draw a picture to make sure that this part, if the work has not been done in work center 1, it can't be processed in work center 2. Makes sense, right? So this is very important. I'm not so good person to draw the picture, but I hope you understand this graph. Okay? But you will have a practice in the homework, and we'll see whether you have similar question in the exam. Any question or comment on using the Johnson's rule? Clear? Everyone? Same page? Okay. Very good. That's for the Johnson's rule. Okay. Now we know how to schedule our jobs if we have to go through the 2 work center. If 3, 4, 5, it just makes it more complex, but the idea is the same. If you need to know, you can use the wiki or Google. You find that in the future if you have to use them in your work. That's what is pretty common situation. Okay, we have to learn that. Okay, we have some general discussion about the difficulty for scheduling. We already see something when we do the example here. For example, we have very strong assumptions on the 2 examples we have went through. I have gone through that. First, we didn't have the fixed setup time. Well, in reality, definitely setup time can be variables, right? Process time, definitely. How can we know the exact process time in advance? There must be some risk. We have longer time or shorter time. But without the fixed time, it's really hard to use any method. Interruption, that's the thing we really hate, but it can happen. Changes in the set of job, that is hard to schedule. If we already have the, okay, DAEC FB, you say another job G come out, you say it's urgent, that is we are just make our orders totally change or maybe mess up. Okay. Except for very small job sets, there's no method to identify an optimal schedule. Let me explain that. Why? There's no method to identify an optimal sequence. You think about that. If we only have 2 jobs, how many total possible sequences with the sets is 2? Possible sequences. And only 2, right? A, B, or B, A, right? I know it's a very trivial question, but I want to begin. That's my style, you know that. Begin with trivial question, understand? What's about 3 jobs? How many total possible sequences?
6.
Hmm?
6.
9?
9.
6? 9?
9.
Huh? 5? Very interesting. Anybody really writes down the possible sequence?
No.
6 is correct. 6 is correct. So basically, it's 2 times 3. Think about it. Okay. If you say A is the first, let's say A is the first, then only 2 sequences, B, C, or C, B. A, B, C, or A, C, B, right? Second, if you say B is the first, that's only A, C, or C, A. So there's 3 possible letters in the first position. So 3 times 2, so 6. So 2, 6. But if that's 6, still we can try each one. and then to calculate the total processing time to find the optimal, right? But if no 6, that's wrong. Okay, think about that. Well, think about it. Some student will ask me, okay, we already know that first come, first serve, EDD, and the SPT, but this is just a typical way, or typical priority. You can have a tremendous different rules. So, theoretically speaking, any sequence is possible. If we ignore the processing, ignore the due dates, right? Any sequence is possible, and it's kind of optimal. So, ideally speaking, if we forget this pre-given priority rule, we have to make all the test all the sequence. So that's 6 in total. Right? Okay, now let's continue. A, B, C, D. How many total possible sequence do we have?
12.
12. Agree with Branko? Do you guys? I don't agree. I don't agree.
Thought it was
Maybe I'm wrong. If you have the best in my side or his side, maybe which side do you want to buy it? I'm just kidding.
16. 16.
16.
Yeah.
1 6.
Mm.
How do you get this magic number?
Well, each letter can be paired up with the 3 different letters.
Mhm.
So if you multiply that by 4 times 4 is 16.
4 times 4.
Yeah.
I think, Jonathan, you're on the absolutely right track. I like your idea, okay. Each letter paired by 3 different letters.
Right.
Okay. We have done for 3 different letters.
Mm-hmm.
Here. 6 possible sequences.
Right.
What about the first position? What's the possible letters for the first position? 4, right?
Yeah, 4.
Which is, should be 4 times what?
3.
4 times 6.
4. Okay.
Right? Because if we say A is in the first position, and then B, C, D, we know that, okay, we have 6 total possible sequence for the B, C, D. If B is in the first position, we have a total 6 different sequence for A, C, D. So that's 4 times 6 is 24. That's already 24. We can still enumerate that, okay, test each possible sequence to calculate the average flow time, average tardiness, average number of jobs. Find the best. What's 24? Only 4 jobs, right? A, B, C, D, E. How many? If you haven't find the rule, you probably can't tell me the results.
120.
Very good. Some students already guessed the rule. A, B, C, D, E, F. Who can tell me?
120 times 6.
Huh?
720.
720. What is the formula? Cameraman, do you already find the formula?
First letter times the amount of the one before minus 1.
So basically, yeah, it's n factorial, or you can write it down as n times n minus 1 times n minus 2 until 1. So that's the formula, right? For example, if 2 times 1 is 2, 3 times 2 times 1, 6, 4 times 3 times 2 times 1, 24 until here. If we think that's way, we can easily prove that. So, no matter, so example 6, let's say 6, okay. The first position we have 6 total possible letters, A, B, C, D, E, F. Each one can be in this position, right? But after we fix first position, let's say A is in the first position. The second position only have 5 possible letters because first position is fixed. So 6 times 5. Okay, similarly for the third position, only 4 possible letters can be in this position. So it's 6 times 5 times 4 times 3 times 1, times 2 times 1, which is n factorial. So this is the math challenge question. Okay, some people did it in high school for the math competition, right? So they will do that, but it's quick exercise. It's easy to understand. Okay, but we can see that the problem is here when the job size increase not dramatically, only 10 or 8. That's a lot more than 1,000 sequence we have to test. We have to calculate every flow time, every tardiness, or every number of jobs to find the best optimal. Just a lot of time or energy to do that. So that's why we say, if we have a big job set, it's really hard to find the optimal schedule. With the supercomputer, we can do that, but still, okay, it's an exponential way to increase. If you have in the computer science, that means, okay, this algorithm, the complexity for this algorithm increase by exponentially, which is hard. That's why we said why it's true. And also, it's not an exact science. Here we only consider like processing time, setup time, something. But scheduling usually involve people, right? You prefer work on Monday. You prefer on Wednesday. Okay. If I only consider minimize total process, maybe you quit next week. Then what's happened? So it's not exact science for sure. Okay. So that's where make our schedule very difficult. But for mathematical way, you can see that very clearly. It's really hard. Okay. Except we have the prior given some priority rule. Like first come, first serve, earliest due date, shortest process time. We know this rule. Then it's easy to make the sequence. Otherwise, to enumerate all the possible sequence, it's just too many for us. It's clear for you guys? Okay. Great. It's ongoing task. But still, we want to minimize the schedule difficulty. First, we need to set a realistic due date, because that's a lot of things to do. Okay. Bottleneck is very important thing we should pay extra attention to. We try to increase the capacity of the operation. If it's not possible, we want to schedule the bottleneck operation first, and schedule non-bottleneck operation around the bottleneck operation. It's easy to understand because bottleneck is the thing we want to first identify. Okay, if let's say JJ is the bottleneck again, why I said it again? Okay, but anyway, you are the bottleneck again. So we want to the job first go to your place to make sure, okay, what is your output rate? And then we can schedule other people based on your output rate. Because otherwise, Jonas is idle, wait for you for hour, right? If I know you are the bottleneck, let's test you first, and then schedule Jonas after you. He knows that's what's your efficient. Then we can schedule some part-time for him, right? Because I don't want to waste everybody's time. So that's why we want to schedule first. And if you are really bottleneck, it's just you are overburdened, you are really expert. Only you can handle this situation, right? Then we have to consider the loss splitting of large jobs to make your life easier. Theory of constraints is similar to the theory of bottleneck. If the production planning approach that is emphasize balance flow throughout the system and pursue a potential 5-step improvement process centered around the system currently most restrict constraints. Since we know the bottleneck, either it's a person or working center or machine, that is the limitation for the whole system outputs. It's very important we want to break through the bottleneck. Okay, either by the training, maybe schedule another person to help you, split the job, but anyway we can think about to break through the bottleneck. Drum buffer role. Drum is a schedule and the buffer is potential constraining resource outside the bottleneck. And role represents synchronizing the sequence of operation to ensure effective use of bottleneck operation. Basically speaking is that since you are already the bottleneck, I want you to work 100% efficiency. Because the efficiency for you is so critical. I don't care if Jonathan look at internet or 1 hour, since he's not the bottleneck. Right? So for you, I have to keep eyes on you. Okay. So that's a theory, right? So if the batch size is different, we can achieve great output bottleneck. Right? So we know that's the economy of quantity, EPQ model, that's what we have discussed. We also can use transfer batch, so the quantity transported from one operation to another. How to improve the bottleneck? We have to follow these 5 steps. First, to determine which person, which step is the bottleneck, has the constraints. We explore this one. Okay, if that's a person, maybe that's just your position not good, you just work or run for a long time, you get your task. Maybe you need the skill set is not enough in the more training, or just simply maybe you are not in a very good mood, just have a bad relationship with a girlfriend. Okay, then something can happen, right? We can't help in this situation. But for others, probably we can provide some help. But we want to identify and explore the constraints. Subordinate everything to the constraints. Okay, Jonathan maybe can help you, right? Maybe some other people can help you. That's what we want to subordinate. That's the bottleneck. And determine how to overcome. Maybe some other colleague can help, maybe training program, maybe simply help another employee. to help him or replace this employee. A machine is the same, upgrade the machine. Okay, if JJ gets the bachelor degree or even MBA degree from UNCP and JJ is a superstar in our production line later, he's not a bottleneck. Okay, now Jonathan become bottleneck. Okay, repeat the project, find the next bottleneck. It can change right every day. Right? Then we have to help Jonas. Maybe another problem with the girlfriend, right? We can't help. But something else we can help, right? Schedule, we can talk about schedule, right? To help him. So this is a continual improvement process. We find the bottleneck, we break through that. Ideally speaking, we want all the people in this production line has very similar output rates. Very similar, right? Then everybody work 8 hours efficiently. Otherwise, unbalanced situation will create problems. So that's the general idea for this theory. There's 3 important metrics for the constraints. So throughput rate, which is the rate at which the system generates money through the sales. Okay. Inventory. You understand what inventory means? I've spent 3 weeks on this inventory. Operation expense is the money that the system spends to convert inventory into throughput, including, for example, utilities, scrap, depreciation, and blah blah. So service operation jobs. You have to remember in every chapter, if we talk about service, usually it's more challenging than manufacturing. From forecasting, inventory we don't have service, but from quality control, right? From location planning, okay, service factor rating, right? So almost every time we talk about service industry, it's become more complex than the manufacturing. Here is the same. Okay. Scheduling in the service industry often presents more challenges, which are not founded in manufacturing industry. Because there are several reasons. First reason about chapter 13, inventory management. For service, we don't have inventory. We can't store our stuff here, wait for a customer. So if customer come with a human being or whatever machine has to be present there. Okay. On time. The second is this random nature. Assuming that usually we have to deal with customers, deal with human beings. Human beings, frankly speaking, we are not so stable, right? Yeah, unfortunately, that's a tragedy happened last weekend in Paris. So we are human beings. We have to say, even that the Second World War has ended for 70 years, right? That's exact 70 years this year. Okay, the last World War ended for 70 years, but in the past 70 years, they never end. Small conflicts, terrorists never end. So for the customer is not like that, but still, there can be happy mood or unhappy mood, some problem with customers. So the random nature of our customers is really hard to forecast. And we know that for schedule, we need to have a good forecast first, right? So it involves customers, work center, and the equipment, which can be pretty challenging. Well, I can't propose a solution for this. We can only point out difficulties. But solution is really depends on your industry. But I want to say, first, demand forecast is very important. Even we know that random nature for the service, but we can still improve our forecast. Then use the method we have introduced here, different prior rule, first come, first serve for the fast food industry, right? Early students for some other industry, right? Like the emergency, okay, rush order for the hospital, especially the ER. So we use different priority rule with very good demand forecast. Hopefully we can schedule our service industry job very good. Oh, by the way, do you have any friend in Paris? No? I have 3 friends, including my cousin. She is in Paris now. She's studying her Master of Finance degree in Paris. So my uncle really worried about her. But I have 2 friends who work in Paris. So it's really on Friday evening I have to keep contact with them constantly, especially my cousin. She's only 25 years old as a girl, so you know that is pretty terrifying situation for her. So hopefully there's no more tragedy happen in the future, at least in the near future. Okay. Continue our study. Okay, schedule service operation. Again, demand forecast. Demand management is so important, but for the serving that is really hard. That's why we introduced this system. How does appointment system improve our demand management? How it can improve our demand management?
I mean, you could kind of have like you could schedule all your people for like the morning hours of like 8 to 11 to get all your appointment time instead of time later, like forecast your demand.
That's great. But you are already beyond what's my question. My question, in fact, is generally speaking, you know the demand in advance with the appointment system, right? You know demand in advance, but you're going a further step. You just know, those only know demand. You can hopefully schedule demand to smooth the demand. That's chapter 3 I've discussed, right? For example, demand usually like afternoon have higher demand than morning. With appointments, you can try to first move some customer demand from afternoon to morning. It's even better than no advance. You prepare that, very good. Okay, reservation system is similar, right? It's enable to fairly accurate estimation of demand. No, but still, there's many of us we like to walk in. Right? That's the one thing I don't like the U.S. How do you say, medical service system. Always ask appointments. Right? In China, or I think Korea, same. There are lots of walk-in clinical or even hospital charge a little bit more than appointment. That's very similar. But here, it's always ER. That's a huge bill. So, but I understand. Well, with this system, as operation management person, I know that definitely we like this system. Right? We don't want surprise demand. Okay, capacity management. Another important thing. We want to have a capacity with a good demand forecast, demand management. We want to have enough employees to satisfy our customers. Cyclic scheduling are widely used in these situations. Okay. What is cyclic scheduling? So, in many environments, the schedule require are very similar to each other. For example, hospitals, police departments, fire departments, or even restaurants or supermarkets. It's like a week, okay, scheduling or monthly schedule. It's happen again and again. It's cyclical schedule. It's rotating. You have a schedule horizon like 7 days, a week, or 30 days. We have to identify the work pattern and develop a basic employee schedule and assign employee to the schedule. The reason cyclic schedule is so popular for so many different industry, hospital, police departments, or fire departments that the demand has very strong cyclical pattern. Right? For example, seasonality, we know that. Okay, every Walmart for the line of probably not Best Buy and Target, probably they already have a lot of temporary employee to prepare what? Very soon.
Christmas season.
Yeah, Black Christmas and also Black Friday. Right? Because they know that every year it's happened. That's almost no surprise. If we come back to the very shorter period, like weekly period, supermarkets. What are the busiest time for weekly base for supermarket? In your opinion?
Thursday, Friday, Monday.
Probably not Thursday, but Friday, and also probably weekend, Saturday. Okay, right. Everybody go to shopping, but especially for this region, probably Sunday morning is not so busy because many people go to church. But different area have different pattern. For some area, there's not many people don't go to church. That Sunday morning can also be very big. So, in your area, there's a pattern. Even for the supermarket, it's a pattern. Okay. For police department, I don't know. Maybe Friday evening or Saturday evening, that can be a problem. I don't know. Okay. Fire department, I have no idea. But that's some pattern for those different service industries, right? Then we have to use the rotating schedule. Here's an example. I will introduce how to make the schedule for this situation. So in a working center, employee work 5 continuous days and have 2 continuous days off per week. Below is the list of starting lead for the schedule cycle. We want to determine the minimal number of work needed and the schedule to satisfy the requirement below. You can see here, it's probably like a supermarket, right? Friday, Saturday, and Sunday, we need the most people. Okay, maybe restaurant, I don't know, maybe restaurant, let's say. That's people like to go out for dinner or lunch on weekend. And but Monday, minimize Tuesday, Wednesday, Thursday is okay, but not as high as Friday, Saturday, Sunday. Now we have to determine how many, let's say, waiters and waitresses we need for this place. Okay, how to do that? And do that together, because you will also have an example, the homework, possibly in your exam. Sunday. So we need 2 waiters and waitresses, 4, 3, 4, 6, 5, 5. Now we have constraints. Okay, employee work 5 continuous days and have 2 days rest. Right, that's the way we how to do that. First, make the first work assignment such as 2 days with the lowest demand or lead are designed to stay off. So you can see Monday and Tuesday together, 2 continuous days, has the lowest total demand. Right? Agree with me? Monday, Tuesday together. We want the first employee, let's say Jonathan, first employee, we want you to work from Wednesday to Sunday. Why we should use this way? Yeah, this textbook told us. Yeah, that's one answer. But intuitively speaking, why we should first schedule employee work on 5 Wednesday to Sunday? So that's reasonable.
Wait, say that again?
Why we want to make Jonathan work from Wednesday to Sunday and have a rest on Monday and Tuesday? In your opinion, in common sense, do you think it's reasonable schedule? Because Monday, Tuesday has the lowest demand. We want Jonathan take a rest when we have the lowest demand. But with a higher demand, we want him to work. Does this make sense?
Yes.
Yes, right? Because if we only have 1 people, well, these people work for the most efficient days, which is Wednesday to Sunday. Monday, Tuesday, since the demand is low, maybe I'm the boss, I'm the owner. Maybe I will serve my customers, right? But Wednesday to Sunday, no way, I can't do that. Okay, done. Next one. Second employee. Cameraman. Okay. If Jonathan work for Monday, Tuesday, have rest for Monday, Tuesday, and we have to update our demand because we still need 2 people here, right? 4 people. How many people we need for Wednesday now? Jonathan already worked from Wednesday to Sunday. Then how many we need?
2.
2. What about Thursday? 3, 5, 4. Great. Now, cameraman come out. Which 2 days we should let cameraman have rest? Remember, we have to be 2 continuous days. Which 2 continuous days?
Wednesday.
Wednesday and Thursday, very good. Because the summation is 5, right? Again, I don't want he to be lazy. I want him to have a big burden. So
why? Can you explain how did you get the numbers for the second row again?
because you work from Wednesday to Sunday.
Right.
Then we need 3 people on Wednesday, but you already count for 1 person, right? So I only need the rest. Now I schedule the second person. The updated demand after I schedule you is changed here. Okay. A cameraman work from Friday to Tuesday and take a rest on Wednesday and Thursday. Now we have to update our demand again to 4. It's not 2, 4. 1, 3, 2, 3, 4, 3, 3. And here. Now the bill come out. So which days we should let him have a rest?
Can you do Sunday and Monday or no?
Sunday or Monday? Sunday and Monday.
Monday.
Okay. Or Monday and Tuesday. The same, right? Because of hybrid. But it's very good. You want to remember that this is a cycle. Sunday is continuous with Monday. Some people may forget about that because they're continuous. So we should take this approach. Let's try this one. Sunday and Monday. Your schedule, right? Have Sunday off. Okay. There's still 1, 2, 1, 2, 3, 2, 3. No? JJ. Okay, our bottleneck come out. Just kidding. Now it's not superstar. Okay. Which 2 days we should have? Let JJ have take a rest. JJ, your opinion?
So work also.
Thursday and Wednesday.
Tuesday and Wednesday. Yeah. Or Monday, Tuesday, same. Let's say Tuesday, Wednesday, follow your personal preference. Okay. Now you have 0, 2, 1, 1, 2, 1, 2. And Xueqing. Now, which 2 days we should let her have a rest?
Monday, Tuesday.
Monday,
Wednesday, Thursday.
it's another break, right? The same, right? Let's say Wednesday, Thursday. It's since it's already 0, that's 1, 1, 1, 0, 1. And come back to the Christine. Christine come out. Okay, then we have to schedule her. So which 2 days you should let Christine take off?
Friday and Saturday.
Friday and Saturday. Oh. Yeah, but because there's a lot of combination like this. Okay. Take Friday and Saturday, 0. Unfortunately, we still need a final person, Branko. Okay, because we still have 1 job left on Friday. Any 2 days take off, but those Friday because I lead you on Friday. Let's say for example on Monday, Tuesday, then we count 0. So basically we do 1 person, 2, Jonathan, 1, 2, 3, 4, 5, 6, 7. So that right, we do 7 people. Then we set up demand for all the customers. That's the way how we schedule in this cyclical situation. Clear for everyone? Very good. So that's cyclical scheduling.
Chris, you need 7 people?
Yeah. You can see here. First one, Jonathan, Monday, Tuesday off. And second, cameraman, Wednesday, Thursday. Matthew, Sunday, Monday. JJ, Tuesday, Wednesday. Xueqing, Wednesday, Thursday. Christine, Friday, Sunday. And yourself, any days except Friday you have to work.
When you just have one person work like 2 hours overtime to cover that one shift?
You mean 2 days?
Or yeah, just have like mix up some overtime amongst the 6 employees?
What's your question, man?
Since you only have 1 left on Friday,
You okay? You want to pay Christine extra money? Ask her to work
I'd cut the
for
7.
double counts, or maybe just spread for the rest people. Yeah, this can be a solution. Yeah, because if we have constraints, if we have to have 1 person, let's say Branko, if you think okay, it's just a waste of money to help Branko, right? Because he's useless, right? Just kidding. But if we think it's a waste of money to help him, just spend to work for Friday and then the idol play the iPad for the rest of the day. Then you can spread and give extra money to JJ, right? JJ want to work very hard to get double pay. Then we can do that. But it's beyond the schedule, right? Let's say the schedule, then we have another person. If you want to replace Branko, you are more than welcome. But we do need another person, okay? Your homework, please add another person. You can't say, okay, let's spread. Only 1 work left, spread for all the employees, okay? Your homework exam, make sure you do lead another person, even there's only 1 job left. Question or comments? Great. We almost finished all the parts of chapter 16. You know how important of chapter 16. You know, final exam and the homework. Okay. If you have any question, let me know. Alright?
So is this the example that the sample probably?
I don't know. Right? All the examples, we only go through 3 big examples. Yeah, you should review all 3 very carefully. Okay.
Especially the first one.
And yeah, that's for sure.